take amusement parks, for example. As part of the leisure and tourism industry, they contribute millions of dollars every year to our national economy. Developing the technology to create better, more thrilling rides is now a specialised industry. In Queensland, Dreamworld attracts thousands of tourists every week. And the most popular ride is the Tower of Terror. It blasts from 0 to 160 kilometres per hour in just 7 seconds and then travels more than 100 metres skywards.
Roller coasters generally start at point B, they go up the top of a hill and then they roll their way down and come back to where you started from. What Intamin have done with the Tower of Terror was that they thought, well, now why don't we increase that thrill component as you depart, instead of creeping slowly up a hill where you've got time to worry about whether or not you're going to die. They thought, well, let's shoot them out at a great rate of knots, send them vertical into the air, and let them feel they're going to go up and to meet their maker before they're due to go, and then fall backwards back down the hill. We were the first people in the world to reach the magical 100 miles an hour on that ride and 100 yards. I know that's old language, but that was the criteria.
So, what sort of mathematical modelling can be used here to describe the motion? The plan of attack is to find some straight line relationship between variables, or more commonly, derivatives and variables. From this linear relationship, we can find an equation with derivatives in it, called a differential equation. From this, we can find the function. In the Tower of Terror, the horizontal motion given to the car is turned into vertical motion by the curve of the rail. Let's concentrate on the vertical direction and see how the car rises and falls under the influence of gravity. First, look at a diagram of the actual path of the car on the rail. Then we can make a graphical model showing the height on the vertical axis against time on the horizontal axis. This graph is an abstract representation of the vertical motion of the car.